All right, guys, I'm going to go over the answers to the odd ones from the review. All right, so first section here, trying to state the domain for each radical function. All right, we're going to do it interval notation. All right, so first thing you want to notice is with a radical, if it's even, then we have to do some work. If it's odd, which we have here, it's just going to be, there's no restriction. It can be a negative inside there. So it's just negative infinity to infinity, you're done. Okay, you only have to worry about it if it's an even. All right, so number 3, we have an even root. Okay, and this one actually has 2 things we need to worry about. Okay, now we want to make sure that this is positive, right? We want to make sure this is positive. So we need to find what makes this equal to 0. Well, what makes this equal to 0? We set the top equal to 0. So you set x minus 3 equal to 0, and you get 3. So 3 is one of our critical values. However, something else is going on here. Another restriction we have is fractions, which we talked about last unit. All right, you cannot have 0 in the denominator because then it's undefined. So what another critical value is, you set this equal to 0 and get 5. All right, so 3 is a critical value because it makes it equal to 0. 5 is a critical value because it makes the whole thing undefined. All right, 0 in the bottom. So there's 3 areas we need to check. We need it to be positive. If it's negative, we get an imaginary and it's over. This is a square root. Even roots, you have to worry about this. So if I plug in 0, I would get a negative over a positive, which would be a negative. If I plug in 4, something between 3 and 5, I would get a positive over a positive, which is a positive. Something bigger like 10 minus 3 would be a positive. This would be a negative, which means that we get a positive or negative, which is a negative. So the only places where it would be you would have positive in here is between 3 and 5. Now, do I get parentheses or brackets? What this 5 can this be equal to 5? The bottom, no. So that's a parentheses. If this is 3, that means it's 0. Could I have 0 under a square root? Yes. So it's from 3 to 5. The bracket on 3, parentheses on 5. All right, so there is the domain. All right. All right, now we just have to simplify some things here. All right, the 4th root of 32. Well, 32 is 2 to the 5th, right? It's 2 to the 5th, which means I can, all right, my 4th root symbol. All right, I can take out 1, 2, and I would have 1 left over, right? And the 11th, 4 goes in the 11th 3 times. So I can take m cubed, goes on the outside. How many will be left over? Well, that's a lie. 4 goes 11 2 times. I'm being silly. 4 goes 11 2 times with a remainder of 3. So there's 3 left over. So there's 3 on the inside. All right, so it's m squared. All right, because there's 2 groups of 4 that can be taken out. 4 goes 11 2 times, remainder of 3. So 2m squared, 4th root of 2m cubed. All right, 189. All right, well, we don't have to do 189. That's an even. All right, odd, sorry. So I can rewrite this. Remember, this means the square root of 12a cubed over the square root of 25. Well, fortunately for this, square root of 25 is just 5. So I don't need to rationalize here. All right, 12. All right, 12 is 4 times 3. So it's a 2 goes on the outside. All right, and there's a 3 left on the inside. It's 2 root 3. A cubed, we can bring out 2 goes into 3 one time with a remainder of 1. So the answer is 2a cube root 3a all over 5. All right, 9. 3x to the negative 1/2 over 3 to the negative second, x to the negative second. All right, let's rewrite this with all changes positive. This negative 1/2 is to the x, not the 3. So the 3 stays there. The x to the negative 1/2, we move that to the bottom. So now it's to the 1/2. 3 negative second becomes 3 squared. Then I have x to the first. All right. So 3 times 3 squared is 3 cubed, which is 27. 1 minus a half is a half. So it's x, 27x to the 1/2. So if this has to write in radical form, which means x to the 1/2 is what? Square root of x. So 27 root x is our answer. All right. All right, for 11, all right, when we are adding and subtracting radicals, you need to have the same number. So let's go and simplify each of these and see if anything's in common. So the square root of 12 is 4 times 3, so that's 2 root 3. 50 is 25 times 2, which means it's 5 root 2. And 72 is 36 times 2, which is 6 root 2. So I can combine this one and this one because they're the ones that are the same. Can't do anything here. So the 2 root 3, can't do anything with it. Negative 5 root 2 plus 6 root 2. Keep the root 2s, just worry about negative 5 plus 6, which is 1. So just write root 2. 2 root 3 plus root 2 is your answer. All right, 13. Let's distribute this. All right, so negative 2 times root a times root a. Root a times root a is just a. So I get negative 2a. All right. Here I get negative 2 times, well, a times a is a squared, right? Which is going to be a. We'll do that in a second. A squared b to the sixth. Well, I can simplify that to negative 2a minus the square root of a squared is a. A comes on the outside. And b to the sixth is b cubed. So negative 2a minus 2ab cubed. You can't combine them. They're not like terms. All right. 15. All right. 15. We can break this up into the cube root of negative 27y to the 36 over the cube root of 1,000. All right. Which is negative 27. You can have a negative in there. It's fine. It's negative 3. Y to the 36. 3 goes into 36 12 times. So it's y to the 12th. And the cube root of 1,000 is 10. There's your answer. Negative 3 y to the 12th over 10. All right. 17. I'm going to put negative 3 to all these terms first. All right. So that gives me a to the 3 halves. Gives me 3 to the negative third. A to the 2/3 times negative 3 is negative 2. All right, so now all of this, we're going to move up here. This is going to move up here, okay? So 3 to the negative third becomes 3 cubed, which is 27. If I move 2 up there, 3 halves plus 2 is 7 halves. So it's a to the 7 halves. Oops. Write that right, a to the 7 halves, but I have to write it in radical form. So it's 27. A to the 7 halves is the square root of a, all right, the square root of a to the 7th. However, how can I rewrite that? 27a to the square root of a to the 7th is actually, write this in a different, I could simplify that, right? So my answer would be 27. I could take out 3 a's, right? Because it's square with the square root of a. So 27 a cubed square root of a. All right. 19. Negative 1/3. Well, it goes to both of them. That just means that I have 8 to the 1/3. So I have 8 to the 1/3. I have 27 to the 1/3. Okay, and it's negative. All right. All right. Since this is negative, right? These are going to flip flop. All right. So what is the cube root of 8? It's 2. What is the cube root of 27? It's 3, and there's a negative there. So it's negative 3 halves. All right. Negative 3 halves. All right. 21. When you are multiplying and you have the same base, what do you do with the exponents? You add them. So you're basically doing x over 2 minus x over 3. All right. Now, they have don't have like terms, right? So like denominators, I mean. So really, if I make it 6, right, this is 3x, this is 2x. 3x minus 2x is x over 6. So it's b to the x over 6 power. But it needs to be rewritten in radical form. So it's the 6th root, because 6 is on the bottom, of b to the x power. All right, 6 root of b to the x. All right, multiplying, these are conjugates. We don't have to fill everything out. The middle terms will cancel. So it's just 5 times 5, which is 25. 3 root x times 3 root x, which is 3 times 3, which is 9, root x times root x, which is x. So 25 minus 9x is your answer. All right. 25. Okay. 425. All right. You have the cube root of 2 and the 4th root of cube. You can't multiply together. They have different roots. So we need to make these roots the same. So if I get 2 to the 1/3 times 3 to the 1/4, I can't add the exponents, but I can make them have the same root, okay, which is going to be 12. All right. So I can change this to 2 to the 4/12 times 3 to the 3/12, which is really the 12th root of 2 to the 4th times the 12th root of 3 cubed. All right. Now, the 2 to the 4th is what? 16. 3 cubed is 27. All right. So the answer is the 12th root. I believe that is 432. All right. So it's a 12th root of 432 is your answer. All right. 27. Add radicals. They're all the same. So you just have to do 2/3 plus 5/11ths, which is, if I make common denominator of 33, sorry, that would be 11. That'd be 22 33rds W plus 15 33rds root W. 22 plus 15 to be 37 over 33 root W. There's your answer. All right, 29. -5 cube root 7,000. 7,000 is 1,000 times 7. All right, what's the cube root of 1,000? It's 10. All right, so it's -5 times 10, and then there's a 7 is still left in there. So it's -50 cube root 7. And there's our answer. All right, next page. 31. All right, 31. All right. 31 is a good problem. All right, we're just going to start over here with this one. So this means 30 4th root of 128 divided by the 4th root of 243. Okay. Now, we probably should simplify these first to make this a little bit easier for ourselves. All right, so 128, if you broke that down, actually turns into 2 to the 7th power. All right, because it's 64 times 2. 64 is 2 to the 6. So another one, doesn't really look it's 2 to the 7th. Look like a 27 there, sorry. So it's 2 to the 7th. All right. Then I have 243, which is 3 to the 5th. All right. It's 3 times 3 times 3 times 3 times 3 times 3. All right. 5 times. So then, all right, even before I rationalize this, let's make this even easier for ourselves. On top, it should be 30. If it's 2 to the 7th, I can take out a 2. Like 4 goes into 7 one time. So I can take out 1, 2 with 3 left over, right? Which is 8, and this is going to end up being 60. And then here, I could take out 1, 3, right? Because 4 goes into 5 one time with a remainder of 1. All right? So I have 60 fourth root of 8 over 3, fourth root 3. Now, some of you might notice could make something even easier. The 60 and the 3, since we're on the outside, I can make this a 20, and the 3 is gone. All right. So I can't have the fourth root of 3. So I need to multiply by the fourth root of something on the top and the bottom. But I want this needs to be a perfect fourth. So I have 3 to the first. I want 3 to the fourth. What do I need there? 3 cubed, which is 27. All right. So you do 8 times 27, which is 216. All right. And there is a 20 on the outside. All right. And then this is 3 to the fourth. So my final answer, all right, I can't do anything. So it's 20, fourth root of 216. And I know I can't break anything down. So how did I get 216? It was 8, which is 2 cubed, and 27, which is 3 cubed. There's no 4s of anything, of any number. So I know I can't break that down anymore. And that's just 3. So 20, fourth root of 216 over 3. If you can understand this problem, you're going to get any of the radicals with the division that there is. This one was a good problem. All right, 33. All right, so we can split this up. Negative 6 over 8, and then negative root 12 is 2i root 3 over 8. And then we simplify that, negative 3/4 plus I root 3 over 4. Remember, since it is a imaginary, you have to write it this way. All right. All right, this one here. All right, we have the square root of 243. All right, and the 5 root 27 x is 7. 243, which from the previous problem we know is 3 to the 5th. So I can take out 2 sets of 3's, which 3 times 3 is 9. So this is 9 root 3. Square root of 27 is 9 times 3, which I can take out. So it's 3 cubed. I can take out 1 3. It's giving me a 15 x cubed, and then a 3x. All right. So now that I've simplified that, now I need to multiply by the square root of 3x. All right. On the top and the bottom. So 9 root 3 times root 3x is 9 root 9x, but root 9 is 3, so 9 times 3 is 27 root x over 15x cubed. Root 3x times root 3x is 3x. 3x times 15x cubed is 45 x to the 4th. And you probably notice we could have here simplify the 9 and the 15 to start, but we didn't. So what goes in? 9 goes into that 3 times. 9 goes into that 5. So I get 3 root x over 5x to the 4th. All right, 37. Negative 2y root 4 cubed. Okay, so this means I have to do the cube to all of these. All right, so this is negative 2 cubed, y cubed, square root of 4 cubed, y cubed. All right, so negative 2 cubed is negative 8. We got a y cubed. The square root of 4 cubed. 4 cubed is 64, which is an 8. All right, then we have the square root of y cubed, which is y, square root of y. So you get negative 64. Y cubed times y is y to the 4th, square root of y. All right, and there's your answer. All right, last one. All right, So we need to multiply by a conjugate here, okay? So we are multiplying by 5 root 2 minus the square root of 6. 5 root 2, sorry, it's really messy, minus the square root of 6. All right, so I'm going to put this down here so there's a little bit more room. I can still see you. Okay. All right, so I'm going to distribute this. 3 root 5 times 5 root 2 is 15 root 10 minus 3 root 5 times root 6 is 3 root 30. All right, so that's the top. The bottom, we have conjugates. So you just multiply the first, last. So 5 root 2 times 5 root 2 is 5 times 5 is 25. Root 2 times root 2 is 2, which is 50. All right, then I get root 6 times root 6, which is 6. So I get 50 minus 6. All right, so root 10, root 30, they're not the same. You can't combine them. You can't do anything else. They're broken down as much as possible. So the answer is 15 root 10 minus 3 root 30 over 50 minus 6, which is 44. All right. All right. And there are the answers. Hopefully that helped if you had the ones you had any questions on. And you guys don't worry about the evens. You'll doing them next week for more review. All right. Remember, quiz is on Wednesday. All right. Hope you guys take care and have a good one.